Let's talk about reformatting exponential expressions. By that, I mean we're going to answer questions that have these directions you see here. Write the function in the form a times b to the x. All right, so before we get started with our examples, I have a list of some helpful exponent rules up here. So we have x to the a times x to the b equals x to the a plus b. Essentially, anytime you have the product of two exponentials that have the same base, you can add their exponents. We can also use this in the opposite direction, which is actually going to be more helpful for us in this particular task. So if you start with something raised to an exponent that's addition, you can split it up into these two pieces. Same thing for the next two. So if you have something to an exponent to another exponent, you would multiply them. Or how we're going to use it in this video is if you have an exponent that is multiplication, you can split it back up like this. And then finally, we know that if you have an exponent in a denominator, it's the same as having a negative exponent. Okay, so let's dive into our first example. I have 4 total for this video. The first one is e to the 2x plus 3. So what I want to do is split up these exponents as much as I can, this 2x plus 3, so that I eventually have e to the x kind of separated out or something to the x separated out. And then the a part of my answer is just everything that doesn't have an x in it. All right, so my first move is going to be to split up the 2 and the 3 using our first exponent rule, right? So if you have a sum up here, you can split it into 2 pieces. So I can see that the a is going to be e cubed. It still looks exponential, but there's no x in it, so this is just some number. And then the b is going to come from over here, but it's not quite in the right format yet. So e to the 2x, I can write as e squared to the x. So I'm going to keep my e cubed out front as the a, and then e to the 2x is e squared to the x. So this is my a, and this is my b. The reason that this would be a useful task is if you get a function that looks like this, it doesn't quite look like a regular exponential, so we may not be able to imagine easily what its graph looks like. But once we have it in this format, we can see it's some number times a regular exponential. E squared is like 2.7-ish squared, so this base is greater than 1. So if I needed to very quickly sketch this graph, I could do it. All right, let's keep going with some more examples. Here we have 10 times 2 to the 3x minus 1. This will be very similar steps as the previous example. I just also have a times 10 out front, which will become part of the a in the answer. So I'm going to start by splitting up 2 to the 3x minus 1 into 2 to the 3x times 2 to the minus 1. The 10 and the 2 to the negative 1, those are the pieces that don't have x's in them. So I'm going to put them together, and that'll make the a part of my answer. And then 2 to the 3x, I'm going to do something similar as I did here. I can make this 2 to the 3 to the x. And I also want to notice 2 to the negative 1 power is 1/2. So 10 times 1/2 can just be 5. So I have 5 times 2 cubed to the x. And this one, because 2 cubed is 2 times 2 times 2, which is 8, I can actually go one more step and write this as 5 times 8 to the x. All right, let's do our third of 4 total examples, 4 over 3 to the 5 minus x. I'm going to start this the same way as the previous ones, where I split up 3 to the 5 minus x into 2 powers of 3. I will say that's not the only way to get started here, but I'm trying to, I don't know, make a theme so that we kind of have a game plan to start with anytime we see these. So one way to start is to split up that 3. So it's 3 to the 5, 3 to the minus x. The 4 and the 3 to the 5 don't have any x in them, so those are going to be the a. And then I have 1 over 3 to the negative x, and this is the part that I want to write as just something raised to the x power. I have a couple of options here. One thing I might do is, because this exponent is negative, rewrite this in its non-negative form to kind of get that negative out of there. So 4 over 3 to the 5th, 1 over. So 3 to the negative x is 1 over 3 to the x. 1 over 3 to the x is actually just 3 to the x. So this right here is 1 times 3 to the x over 1, which is 3 to the x. So I have 4 over 3 to the 5th times just 3 to the x. And this is actually in the format that I need for my final answer. Another option from this moment right here with 3 to the negative x in this denominator would be to separate the minus sign from the x. I'll switch colors just to show this is an option here. You could have called it 3 to the negative 1 to the x, which is 1/3 to the x. 1 over 1/3 to the x is also going to get you over here. So you have a bunch of different options here, but they should all land on this final answer. All right, let's do our final example for this video. This one has a different format from the rest of them in that there's more than one x in the original expression here. So right now, how it is, it doesn't look anything like one of our exponential functions. So sketching this graph would not be particularly easy, but we can still use our exponent rules to get this into that same form. So for both of these pieces with the 3 and the 4, I'm going to do that trick that I started all the others with. So separate it out into 3 to the x, 3 to the 1, 4 to the x, 4 to the negative 2. Okay, so I want this 3 to the x and this 4 to the x to come together. And then the other stuff that doesn't have x's, I want them to get together as well. All right, so we'll do 3 to the 1, I'll just write as 3, times 4 to the negative 2. I'm just changing the order here so that they're next to what they're going to combine with. 4 to the negative 2 is 1 over 4 squared, so 1/16. So this constant at the end will be 3 over 16 to kind of combine 3 times 1/16. And then here I have two different b to the x's, which doesn't quite fit into the format that was requested. But if we have 3 to the x times 4 to the x, this can combine to 3 times 4 to the x power. So this is 12 to the x. And that's my final answer.